we're sitting here in our demo lab, our new IoT and design lab, and I'm just going to stop the spotlight on me so you guys can see the slide. Our new IoT design lab, and yeah, we have a few interesting things here with IoT and combining that with supply chains, and we have some component library. But I would like to invite you, an open invitation for when things are a bit more physically meeting friendly, to come out here and visit and see some of the demos and some of the solutions that we have out here. This webinar, and actually it's a series of 4 webinars, is a part of one of our performance contracts, one of the activity plans for the performance contracts going in 2019 and 2020. And this one is about advanced real-time monitoring in supply chains. You can read a bit more about that in this, through this link on our webpage. And yeah, so today is the first webinar. We're going to have one more the 18th of November in 14 days. And then this one is going to be about IoT for service and maintenance in supply chains. We're going to continue that with one the 25th of November and one the 2nd of December, all starting at 8 for half an hour. If you guys have any questions along the way, you are welcome to go to menti.com, use this code. Mads, he's also gonna post the link in the comments, so you can just click that link, copy the code and post that in. And then we also prepared just a few questions for you guys, just to see a bit about what you find interesting and what you are up to out there. But for the better experience of the webinar, I'd like to ask you guys to keep your microphones and your camera turned off. Yeah. And then let's get started with the webinar. I'll hand over the slides to you, Michele.
Yes, I will share my screen.
I will just stop sharing. There we go.
Fantastic. Can you see my screen?
Yes.
Very good. So good morning, everybody. My name is Michele Colli, and I'm an industrial IoT specialist at Force Technology. I joined Force Technology after doing a PhD in digital supply chain. So this is the field where I've been working with also in the past years. And today we are going to have, since it's the first webinar of this series, a quick overview and introduction to supply chains and how supply chains are evolving right now in this new Industry 4.0 era. A little background of who I am. I have a background in mechanical engineering from the University of Bergamo in northern Italy, where I come from, and where I've been a musician for a few years. I moved to Denmark in 2015, where I did a master in manufacturing technology at Aalborg University. And in 2017, I started a PhD there studying the digital transformation of supply chains and the whole Industry 4.0 agenda. After that, I joined Force Technology as a business consultant dealing with industrial IoT, digital transformation, digital maturity, and so on. So let's get started. I guess you are more or less all familiar with what is the concept behind Industry 4.0. But in short, we know that it's considered to be the fourth industrial revolution, coming after the first one in late 1700 when steam machine was invented, and factories were invented, so a completely new way to organize production. The second one, where we had electricity coming in, and from an organizational perspective, we had the advent of Taylorism, Fordism, so mass production and assembly line concepts. The third one in the 1960s and 70s, where we had PLCs and SCADAs and industrial automation and computers coming into place. And now, built on top of that, what we are calling the fourth industrial revolution, so the one based on cyber physical systems, and more specifically on systems that are capable of generating data, what we saw already in the 70s, but also in collecting them, storing them, sharing them, not only within the factory, but across supply chains. And the core aspect of this industrial revolution is actually data. Why do we have so much data today? Why is it enough to cause an industrial revolution? From the third industrial revolution, from the 1970s, and the first computers and industrial automation, we started generating data. And these data, the generated data, the collected data, now the downloaded data, have an exponential increase. So long story short, today we are completely overwhelmed by data. But why is this revolution happening right now? And it's based on data. From an historical perspective, we had in the late 1980s and in the 1990s, especially, the offshoring phenomenon. So when manufacturing companies from high labor cost countries started moving their production in a low labor cost country, mostly Far East. And doing that, it was very beneficial from a business perspective, but in the beginning of 2010s, we figured out that Western countries' economies, without having a strong manufacturing textures, weaker. So the German government started an investigation trying to look at potential new competitiveness lever that manufacturing companies could use in order to be competitive in high labor cost countries. And even to facilitate a reshore, so a coming back of the manufacturing plants that they have been moving to Far East. After this investigation, they figured out that the main potential competitiveness lever was actually the use of all these data that were coming out. And so they started what we know as the Industry 4.0 agenda. And shortly after, they invested in 2014 400 million euro into that, and then in 2017 they reached 2 billion euro investment. And the other countries in Europe and also in North America, now all over the world, they started a similar agenda to look into the use of data and connectivity into their supply chains and manufacturing domains to improve competitiveness. What is this whole thing about? Well, we already had plenty of data inside our companies. In fact, about 90% of the business processes were already in the early zeros supported by IT. What changes a lot is that we are going from the classic automation pyramid, which is based on the use of PLCs, SCADA systems to generate data and collect data, a MES system to organize them, an ERP system to have control, so virtualization, to a network of node, meaning that with these new connectivity capabilities, we started being able in making machines communicate together or communicate with other machines or entities across the same supply chains or different supply chains. Doing this, the transition became from a vertical integration to a vertical and horizontal integration, so across our supply chains. From a larger perspective, This leads us to what Porter and Heppelman in 2014 already visioned and called a system of systems. So going from the classic products and products that can generate and collect data and be able to show the user, for instance, their operating condition, to products that they're able to communicate with other products or systems across their own supply chains or different supply chains, and also take advantage of the data that come from their supply chain. This is an example made out of the farming industry. Actually, last night I was talking to a friend exactly on the use of IoT in the farming industry, what has been called a lot as smart agriculture. And this example shows us how going from a tractor and being able to put intelligence, put sensors on a tractor and collect data concerning how the tractor functions and which ones are the operations the tractor has to do during the day and so on. We are slowly becoming able to make all this information available remotely, having smart and connected products, generating this information and being able to share them with other, for example, other farming equipment within our own systems. It could be from tractors to planters, tillers, and so on. And eventually being able to, for instance, link our old farming equipment to other supply chains, for instance, the one related to weather data systems, and figure out what the weather forecasts will be, what the humidity of our soil in a specific area is today, will be tomorrow, and then forecast how much we will need to water that specific area. This is, in a nutshell, the whole idea of a digital supply chain. So the concept of having multiple systems, collecting data, sharing data between each other, and also across different supply chains and with other systems. The whole goal in the end is to have enough data to support and optimize decision-making processes. There are a number. Yes.
Well, can I ask you a question quickly? Because I think this, I know you and we've talked about this a few times, but I think it's very interesting, and especially with the system of systems, and it seems like this is going to make a huge impact on and a big change in our society. I know it's a big question, but can you say a bit about how might this impact our society?
Yes. One interesting thing is that partly our society has been already impacted by these type of technologies because we have been using data, we have been using connectivity in our lives way before the advent of Industry 4.0, so of the use of these data and connectivity capabilities in industry. So partly, if we think about using Google, using social networks and so on, smart homes, we are already using this type of technology in our lives. From an industrial perspective, this is for sure going to change the way we perform decisions, but especially who performs decision and which decisions we perform. What do I mean? I mean that it's already obvious how some jobs are going to get replaced by automation, and I'm thinking about automation in decision-making processes, not only in actual physical processes, but also how we have more and more new competencies coming up. So I think that the main thing that we will experience, and we are already experiencing, is this shift in competencies needed in industry. I think that especially in this moment, the advantage in having this type of technologies, and we all see that having this type of pandemic situation going on, is that it makes our supply chains more resilient, and it supports us in performing our job even when we are not there. And today, this starts being a very good advantage. So I think this will be the main changes.
Cool. Thanks.
In order to enable the improvement of the achievement of competitiveness, this agenda includes a big number of both new and old technologies, and Boston Consulting Group in 2017 clustered them in 9 main families. Now, we don't have the time to go through all of them, but what I would like to point out is that the backbone, first of all, that most of them, they work together. So we don't have to look at them as single clusters, but most of them, they look together. Let's think about system integration, Internet of Things, big data, and cybersecurity. But we have to remember that the whole backbone of the use of these technologies is actually the Internet of Things. So it's the enabling of this network of nodes and of our capability to generate, collect, share, and use data that come from across our systems. The classic IoT infrastructure, just to have an idea of how in a very simplified way how it works, is to have assets, machines that generate data from their sensors and their PLCs, and they are able to transmit them to the cloud or to databases using a gateway. And the cloud is going to be able and is able to process these data, analyze them, store them, and send them to dashboard solutions that make them visible and support or perform decision-making processes. We see that these type of infrastructures, the use of IoT as a backbone for the digital transformation, is currently being deployed in 4 main fields, and we see it from both our research projects and consultancy projects. And what we observe is that we have these 4 main fields concern, firstly, production planning. There is a lot of interest and a lot of use of IoT for linking orders and forecasts to current stock and available resources in order either to automate the planning process or to optimize it. Secondly, on the production floor, there is a lot of interest and a lot of low-hanging fruits lying into the use of IoT and the integration of sensors in production to monitor different production parameters, such as the OEE and quality parameters, in order to be able to keep the processes in control. Third, there is a lot of interest in logistics. And in this case, it's mostly concerning both the location of equipment, and we can think about yes, our package being delivered to us or delivered to our customers, but also the location of equipment that we are using for production. In the building industry, there is a huge interest in locating buckets, for example, because building industry has very large spaces and a lot of different equipment. It takes a lot of time to find it. So to locate it becomes crucial to optimize the operations, and partly also to verify the availability of these equipment. Let's think about transport equipment we have in large warehouses. It's important for us to know how many transport structures we have available in order to make sure that we can sustain our operations. And fourth, and this is probably the field which at the moment we are seeing as the main ones in terms of emergence, is the service and maintenance field. There is a lot of work concerning the monitoring of the conditions of the equipment, mostly to improve the uptime, improve the availability of our machines and production line, and to shift from the currently classic time-based maintenance to condition-based maintenance, and eventually to predictive maintenance. And this is actually what we are going to discuss more in depth during the next seminar. There are plenty of promises concerning the use of digital technologies in these areas, and this is what McKinsey presented in 2015, and obviously the numbers are a big guess. But indeed, what is interesting to see are the value drivers. The fact that, yes, we are going to address asset utilization. We are going to address productivity increase. We are going to address maintenance costs. We are going to address time to market and so on. Although, even though we have so many interesting promises, we have to remember, as Ulrich Berger, a professor from TU Brandenburg, used to say, Industry 4.0 is not a free lunch. We have a number of challenges that we have to take care of, and the main ones emerging are partly regarding data sharing and IT security. So firstly, the fact that we need to be able to strategically decide what to share and to whom. And from an IT security point of view, obviously, ensure that what we are sharing is secured across the partners we want to share it with. We have standardization issues. One crucial aspect is interoperability. So the fact that we can actually communicate with other partners across our supply chains from a technology perspective. And then there is the problem of the business case. This we are seeing that, and a lot of research is highlighting how all these digital transformation projects and new technology integration projects are often suffering and not succeeding because companies don't see a clear or a positive business case, or don't see any low-hanging fruits. So this is a very, very big challenge, and actually the main barrier for digital transformation. We will see in a minute how we could take care of that, how we could try to address that. Another barrier is concerning the complexity. We have many different technologies at many different levels of complexity, and especially in the first phases can be very challenged to align the complexity of the technologies of the projects we want to embark with our current capabilities. And lately, one key element that emerged was the need for dealing with the high level of uncertainty we have in these projects, and the need for agility in order to deal with it. Now, how do we deal with this complexity? There has been a lot of research, a lot of discussions concerning the use of digital maturity to deal with this need for aligning technology integration and digital technology integration projects with available capabilities. And we will not dig into this right now, but to provide you with a quick overview on that, many consultants, many research institutions, many universities developed and discussed maturity models that are describing the Industry 4.0 evolution path in a simplified way, highlighting a number of sequential stages which are built on certain cumulative capabilities. And this aims to help companies in identifying where they are, which type of capabilities they have, so identifying which stage they are, and where they can aim having these type of capabilities, and which capabilities they should build next. And looking at all these models, we came out with a model that kind of summarized them from a technological perspective, starting with a zero stage where we have companies with absolutely no digital data. Everything is pen and paper, everything is printed, orders come in through a phone, information across the company are shared through talks, through pen and paper, are not traceable, and so on. Next stage is where we have the generation of digital data and the storage of digital data. And after that, we get to a transparent stage where actually these data are not only in some databases or folders that we need to open and look for, but we actually have these data available in front of us when we need them to support our decision-making processes. So the use of dashboards, for example, that show us data for processes. Then we get to the availability and to the use of analytic capabilities, not only the availability of raw data, but also the capability to analyze them and get further insights concerning our business processes. And eventually, the capability to automatically perform this data generation, collection, analysis, and decision-making process, especially when it's systematic. Yes.
I just wanted to ask Michele, so this term about lights out factory, that's something that we hear quite often. How does that relate to this maturity assessment, a maturity model?
That's a very good point. The term lights out factory or dark factory is something that was originated, mostly discussed in the 1970s when automation started kicking in. And the vision was, okay, now that we know that we can automate processes, in few years, everything will be automated and we will have no workers in factories. Everything will be automatic. In the beginning, of course, this did not happen for many reasons. And in the beginning of the fourth industrial revolution, of these types of discussions, the idea for some research institutions was also that the maximum level of maturity was the one where we did not have to perform any decision-making processes. All the decision-making processes were automated. In fact, this changed over the last few years, and now the vision is more, okay, we are going to automate all the decision-making processes that are systematic, but the ultimate goal of the digital transformation of the use of IoT is to provide the best support we can to empower humans. So now human is considered to be in the center, and IoT to support the human doing in an optimal way its own processes. So this is the vision right now, and there has been indeed a shift. Yes.
Thanks.
So the use of maturity, aims at matching these innovation initiatives with available capabilities and also in identifying where to grow and how to grow. We also have to consider that there is not only technology. We kind of went through these stages looking into technology, but we have to take care of other dimensions in the company that go from how we manage projects, so the governance part, the competencies we have in the company and how we build them, how we generate value using data, and what is our level of integration, both vertical and horizontal, across the supply chain. From a business value perspective, we said that one big challenge was the fact that it's very difficult sometimes to find a good business case when we deal with innovation projects. And what we observed through our project was that many times a technical solution, a new technology solution, come out of some needs. So there are some issues that a company would like to address, and there is a solution that is built in order to address these issues. And when we assess the business case of this new solution to address that specific issue, many times we don't have a business case. Simple as that. What we identified is that we also need to consider the learnings that come out of this solution. Many times the solution that we develop to address one specific issues are also able to address different issues. What we learn developing that solution can also be used to address something else. And this is what we identified as extended potential. And in a few of other projects, it proved how if we start considering this, the business case eventually changes and company can see value behind innovation and establish a positive business case. A third step is actually how these learnings can support us in fostering further innovation. So in moving along this digital maturity ladder, and this is fostering even more our business cases. To conclude, we said that one big challenge is to find out how to manage the uncertainty of these projects and what we have been noticing and what research is also highlighting is the importance of adapt agile approaches when dealing with innovation projects. So let's think about design thinking, lean startup, Scrum, and so on. So try to build demonstrators of our new technology solutions in quick innovation cycles, moving iteratively with very, very close contact with the user, with the end user of the solution, having periodic feedback, try to fail fast and establish learning practices to understand why we failed and improve the product. And this is actually something that for some of us is the normal way to proceed, but I've been presenting in this webinar, having some American attendants, and they were very interested into that because they have a very, very different concept, very different process when they deal with innovation projects. So they, for instance, do very big analysis, feasibility analysis in the beginning, and then they invest a lot of money into developing one product. While what we tend to do here is to try to go step by step and build minimum viable products, keep on testing them until we get little by little to the end product. And this is something we really need to pay attention to. Thank you very much. I know I've been very quick. I gave you just an overview of the agenda, task few points. Probably you will have some questions, and I'm of course available to that. Thank you.
Thanks a lot, Michele. We're a couple of minutes over time, but we're just going to keep it going just a few minutes because at least there's one question for you, Michele, and it goes: do you see IoT data and blockchain as a match in the future to carry the IoT data around? And if yes, why would that be?
Yes, that's a very good point. Blockchain is definitely an emerging technology. We are talking about blockchain since few years. It's still coming out, but it's concerning when we think about IT security. Blockchain is definitely playing a big role in adapting IoT and making sure that we will be able to share data in a secured way. We've been discussing this a lot. In January, there was one of the biggest IT conferences in Hawaii, and one of the main topics was actually blockchain. And this proves how there is a very, very strong interest into that. Even though from an industrial perspective, now when we integrate IoT, we do not address that issue at the moment. But I think that, yes, in the future, it will be definitely one of the key issues to consider, blockchain.
Great. We're going to stop the webinar for now, but I hope you guys found that interesting. And as you can see here, you're still, you have the possibility to sign up for the next 3 webinars covering these 3 agendas. And just going to say thank you guys for listening and tuning in for now. Keep safe and have a good rest of your day. Bye, guys.
Thank you. Bye.